Welcome, everyone. Thank you for joining us again. So we continue with our next speaker, Sarah Popelka, who is going to be introduced by David. Please, thank you. Floor is yours.
Sarah works as a team lead and geospatial developer for Innovate, Inc., a consulting firm based in Washington, D.C. Her work focuses on projects that promote environmental and social good, as well as building innovative tools to better understand and analyze urban environments. She also collaborates on international research projects as a contributor advisor for Urban AI, a Paris-based think tank that specializes in urban artificial intelligence. She holds a master's degree in urban governance with a specialization in quantitative methods for metropolitan governance from Sciences PO. Please welcome Sarah Popelka.
Thank you so much for that introduction, and thank you so much, Ingrid, and everyone for having me today. Let me just pull up my slides here. Hello, everyone. As the introducer mentioned, my name is Sarah Popelka, and I'm a geospatial developer at Innovate, as well as a contributor and advisor at Urban AI. I'm excited to share some insights on opportunities of AI for human-centered urban planning and design. And I look forward to answering any questions at the end of my presentation. Here's a little bit about the structure of the presentation. I'll introduce the concepts of human-centered urban design and urban AI. I'll walk through some implementations of artificial intelligence to reach those goals of human-centered urban design, and then I'll share some final takeaways. I'd like to begin by discussing urban artificial intelligence. Last year, we at Urban AI released a guide that aims to help urban practitioners better understand artificial intelligence and the ways that it interacts with and impacts our cities. This concept of urban artificial intelligence uses artificial intelligence that feeds off of data produced by and in cities, and it informs decisions that in turn affect the urban fabric and daily lives of residents. From citywide data collection sensors to outputs like autonomous vehicles, it's characterized by a really unique materiality that doesn't exist in other artificial intelligence systems. So for this reason, we created a guide to help urban practitioners understand how to work with this material urban artificial intelligence within their cities, the complex policy structures that they operate in, and then also just that baseline complexity of the city. When we think about human-centered urban design, it's applying a broader design thinking methodology of human-centered design, which places the user at the center of the design process so that the product or system being built prioritizes that user's needs to urban design and urban planning. So cities that are created through this human-centered urban design process are optimized for humans, designed collaboratively, and they're inclusive and supportive of all residents, regardless of social and economic characteristics. Throughout the next few slides, I'll delve deeper into each of these points to show what it means in the context of a city, and also how AI can support designers in promoting each of these areas with their urban designs. First, let's start with optimizing cities for humans. Here's an example of a city that is not optimized for humans. This happens to be an image of a neighborhood in Cairo, but we can see this type of urban design all over the world, and we in the United States are particularly guilty of it. Notice the scale of the urban features. There are extremely long blocks, extremely wide streets, and towering highways that cut through right next to apartment buildings. Here I've highlighted a few pedestrians that are trying to make their way through this neighborhood, crossing this dangerous and large road, which is clearly not built for them or their needs. Over the last few decades, as building technologies have improved, there's been this tendency to build what can be built rather than what should be built. And the lived experience of urban residents is often a forethought or an afterthought. So they're not really considered in some of these like large scale urban designs. However, even if we want to design cities with humans in mind, the results don't always serve the needs of the people that we're designing for. This is a meme that started circling the internet about 9 years ago, and I love what it highlights about human behavior. There's this nice pedestrian space with wide walkways, lots of green space, benches, good lighting, but you can see by this dirt-trodden path that the design doesn't really cater to the needs of the residents. And what they really needed was that diagonal pathway to take them directly to the door that they were trying to enter from the transit station. So, even the best laid intentions can still produce results that don't cater to human needs. In software and product design, we utilize what's called an iterative design process to try to avoid these pitfalls. We come up with an initial idea, build a prototype, and then put it in front of people for testing. I can tell you, I'm consistently amazed by the unexpected ways in which people interact with the systems that I've built, which is good because people are going to use systems in ways that they need to use them for. And I can better understand the ways that the systems can fit those needs and then adapt and adjust the prototype accordingly. So then we put it out for testing again and have people, break it, find things that they want to change. And then we adapt, put it out for testing again and again until we've narrowed in on an application that works for the needs and uses of our users. If we wanted to apply this directly to urban design, the overhead is much greater and iterative design processes can be costly and time-consuming, not to mention dangerous and disruptive. If I wanted to iteratively design a new traffic pattern, say, I couldn't repeatedly dig up roads and reroute them until I found the option that resulted in the fewest vehicle collisions. That would take too much time. It would be really disruptive to the lives of residents. And, anything that might result in death is generally not a good thing to play around with testing. But this is where AI can come in. In order to apply an iterative design process to optimize cities for humans, we can use AI to speed up design cycles and also virtualize them so that we're not impacting our built environment while we're doing the prototyping and testing. We're only impacting a virtual environment. There are a couple of tools that allow us to do that. Generative AI, which produces images and videos based on text prompts. AI-enhanced agent-based modeling, which uses equations and computer-based decision-making to approximate human behaviors. And then you'll often hear that referred to as digital twin. And then there's also augmented reality and virtual reality, which are not AI, but they are important technologies in this context. So first I'll show an example with generative AI. Here's an image that I generated using Google Gemini, using the prompt that you see on the right. Within a matter of seconds, it created this, this area that's pedestrian friendly, mixed use shopping area, green space, and promotes well-being. I'm sure none of this is up to code, but it gives a good starting point for the design of the space. Then let's say I wanted to see some outdoor dining space. All I had to do was add one additional sentence. Can you add some outdoor dining? And the design was transformed again to show, more of an outdoor dining experience. All of this happened within a matter of seconds, and I was able to quickly quickly turn my idea into a design, and then quickly modify the design based on, changing priorities. All of this with traditional design methods would take much longer, and I also don't have the graphic design skills to be able to do this. So AI can be used to speed up these initial design phases, especially when the iterative design process would require a lot of modifications. Using augmented reality and virtual reality, urban designers can also rapidly prototype. This image shows City Engine, which is a product developed by Esri. You can see a digital representation of a city on a tabletop, and that blue feature in the middle is a proposed building. Using special goggles, people can rotate and pan around the scene to understand how the proposed building will fit into the urban fabric and easily make adjustments to the design as needed. Using these technologies, someone can also walk down that actual street in the actual city wearing the goggles and see the proposed design in place, overlaid on whatever is already there. These kinds of technologies provide additional insight beyond what can be produced using a physical model, and they also allow for quicker adjustments. If I wanted to decrease the height of one of the towers, it's the press of a button and it's done. And I can see how that reduction in height plays out with shadows cast on nearby buildings, for example. Finally, agent-based models can be used to estimate how people and cars will move through space, allowing for large-scale testing of proposed designs. This video shows a simplified example of this with cars moving through a city. The agents, those little dots that represent cars, will adapt their behaviors whenever changes are made in the scene. This allows designers to test the potential impacts of their plans. So when thinking about building cities that are optimized for humans, designers can use AI to accelerate and reduce overhead on iterative design processes. Doing so ensures that their proposed designs are tested by and adapted to humans. And in turn, they can identify and account for any pitfalls prior to construction. It's a lot more costly to build a building or build a road and find that it's not going to serve residents' needs or that it's going to have some sort of unidentified problems than it is to catch those problems before the building has been built. Now let's unpack the second element, designing cities collaboratively with residents. I'll show a use case that I'm currently building, which uses a set of tools to involve the public in collaborative design. Here's an image of my neighborhood in the United States. A number of factors, including climate change and less regulated densification in other parts of the city, have led to an increase in major flooding events. As you might imagine, it also leads to a lot of frustration among residents. And progressively, the citizens lose trust in the government every time their basements and homes flood. In order to engage the public in combating this issue and use some of their insights and priorities in designing flood control measures, the city might present some options for stormwater control measures. Here are some options that the city might propose: subsurface infiltration bed, vegetated swale, riparian buffer restoration, dry wells. I'm not a stormwater engineer, and I only have a vague knowledge of what those design options are, let alone how they'll impact me or my neighborhood. If I see these terms, I might not engage in the participatory process because I might be so overwhelmed by the lack of knowledge of what any of those words mean. I also definitely won't be able to contribute my own knowledge about the dynamics of the space. There's a high likelihood that I'll lose trust in the process and be quite discouraged. AI can be used to democratize urban design, allowing citizens to actively engage and participate. The technologies that I introduced in the first section apply here as well, as they reduce the technical overhead needed to participate in the design process. But this particular use case with the flooding uses automated data generation and platform-based analytics to give citizens the tools that they need to participate in decision-making around flood planning in their communities. In order to do any kind of urban modeling, you need spatial data. These data sets can be costly and difficult to obtain, which restricts urban modeling to a select few governments, research institutions, and design firms. But within this project, we aim to put the necessary data in the hands of the community at no cost to community members. Here's a neighborhood in Texas, which is where the project is based. We trained deep learning models to ingest publicly available aerial imagery, which you see in that first image at the top. And it outputs data representing different land cover use types and uses derived from the imagery. So for each set of pixels in that top image, the AI performs a bunch of math to calculate the probability that that particular area represents each of our land use types and outputs the most likely use. Generating such a data set without AI would have required a large team to go out and collect the information, and it would only be able to be done feasibly over a small area. Using AI, we're able to produce the same data at high quality over the scale of states, countries, and it's much easier and cheaper and faster. Once we have that digital representation of the neighborhood, we also need to understand where the floodwaters might go in a baseline scenario. Using a different set of machine learning models, we can predict the severity and directionality of flooding based on the terrain and characteristics of the built environment. It's very hard to see in this bottom image, but each pixel has a value corresponding to the volume of water that might accumulate in that area during a flood. So like you can see along these channels, the lines are darker, so there's higher likelihood that water will pool there. And in some of the other areas, it's a lot lighter, so it's a lower likelihood. Finally, we can combine and overlay those two data products, the land use data and the baseline flood prediction, into a third tool, which allows citizens to introduce stormwater infrastructure and understand the impacts that different options will have on flooding in their community. In that top image, you can see I've highlighted a piece of this parking lot to convert into a park. And then in the bottom image, I've painted a park over that parking lot surface. And I can see how the absorption that having grass in that location, how that will impact the way that floodwaters flow throughout the community. And I can test whether that will divert floodwaters from the homes that are just peeking out at the bottom of the image there. All of this is done by citizens. They don't have any geospatial knowledge. They don't have any stormwater knowledge, but they're able to test the different interventions proposed by the city, and they can see how those different interventions will impact their homes, their lives, and they can also utilize their local knowledge to contribute meaningfully to the design process. All of this allows designers to ensure that resident priorities are being communicated and understood, and that they're building citizen trust. Finally, let's delve into inclusiveness and equity. Not everyone has equal access to the city, and the built form can have tremendous impacts on the spatial distribution of resources and opportunities. This is a very stark example from aerial imagery in South Africa, but a large body of research has shown how inequalities can be perpetuated in cities and how the built form can contribute drastically to segregating people and building in income inequality and health inequality, among other factors. Remember this image because I'll come back to it a bit later. There are a number of examples where AI-based clustering and prediction analytics can help identify and highlight underserved areas and communities so that resources and spatial interventions can be targeted in those locations. Here are a few examples. A number of urban AI community members do work with urban tree canopy and tree health monitoring to ensure that underserved communities can experience the numerous health and environmental benefits of green space without having AI-enabled extraction of tree canopy and estimation of pollution, like carbon sequestration and things like that. It's a lot harder to tell what the benefits of trees are and where those benefits are not being conferred to the community. But AI gives insight into that. AI models can also detect unseen clusters of pollution or disease, giving planners insight into locations to prioritize for land use restrictions or other spatial interventions. I also want to mention autonomous vehicles and drone technology, because that's a set of buzzwords that people often think about when they think about AI in cities. These AI-based transportation and service delivery methods can provide people with more options for moving through and accessing the city. However, I also want to make sure that I emphasize that AI is not a rosy solution. Just as much as it can assist with improving urban design processes, encouraging public participation, and removing urban inequalities, it can also harm people, particularly the most vulnerable community members. There are numerous risks associated with AI, but I wanted to highlight a few here. Given the data-driven nature of AI systems, it's easy to assume that they provide definitive and impartial results. However, like any technology, AI is an artifact of the social processes that surround its development. If we think about that image, AI models have inherent biases. If we think about that image of South Africa that I showed a couple slides ago, many data extraction models would easily identify the apartment blocks that were shown on the right as buildings, but they might not identify the informal housing on the left as structures, due to the fact that they were trained on data that showed more regularized houses and not the haphazard construction of informal communities. This could have the outcome that flood reduction strategies are optimized for the building on the right, while no interventions are made to protect the people on the left. You always need to understand the source of the training data and account for those biases in your analysis. Second, models are dumb. Even if they attempt to incorporate a number of variables and consider a situation from multiple angles, they are only as good as the data they receive and cannot use common sense to extrapolate. Model outputs should always be contextualized and never taken at face value. Finally, models require a lot of data. In the case of generative AI, that's often intellectual property that was scraped from the internet without the creator's knowledge or consent. In the case of urban AI models, it's often urban telemetry data that has been captured from cameras and other sensors without, the data subject's knowledge or consent. This can particularly harm vulnerable communities. So as AI produces human-centered design and infrastructure, it becomes more critical to think about also designing human-centered urban AI. I brought this diagram back to show that we intentionally placed humans throughout this urban artificial intelligence process. So humans in the city, humans having their data being collected by sensors, humans doing the storage and processing, creating the visualizations, overseeing the machine learning methods, and ultimately making the decisions. AI can be really powerful when it comes to fostering human-centered urban planning and design. It can hasten those iterative design processes so that we can introduce rapid prototyping and identify the pitfalls, potential pitfalls of designs before they're implemented in the built environment. It can democratize data and analytic techniques so that members of the community can participate meaningfully in the design process, introducing their own perspectives and local knowledge, and gaining trust in the system. It can also identify and analyze inequalities that would otherwise be invisible to traditional analytic and urban planning techniques. However, urban artificial intelligence holds its greatest value not as a means of making decisions, but as informing them. And it requires a really deep understanding of the social influences in the technology. So I encourage all urban practitioners to formulate some understanding of urban intelligence and its impacts, and to understand how it can both provide opportunities for incorporating human-centered urban design, but also to understand the risks that it might confer on the population, and to correct for those risks if possible. Here I've included a QR code if you want to scan it to read the Urban AI guide that we produced. And I thank you guys so much for listening, and I welcome any questions.
Thank you, Sarah. That was a very interesting talk. But starting earlier in your presentation with this way of using generative AI image models for, making proposals and so on, do you see any risks of outsourcing too much of the decision making to an AI, and like how this might hasten process, meaning that decisions are somehow taken without consideration, which might in the end reduce the quality of a design?
Yeah, absolutely. That's a really big risk of using generative AI along a couple of different lines. So first, generative AI doesn't have that knowledge of what's actually technically feasible. And it also doesn't have that knowledge of what fits within building requirements and building code restrictions in different neighborhoods. So it can produce some beautiful images, but they might not be possible to build given technical or political constraints. And so to that degree, I would kind of argue to use it as a source of inspiration, but certainly not as a design tool. It also is not able to really adapt to like an understanding of project requirements. So when generative AI is creating images or creating text or videos, it's using essentially an impression of what should be produced based on the ways that people have already created images and text. So it kind of follows this train of, if the prompt mentions, let's say, green space, then there's a high likelihood that they might want green space to look like this, because in the entire body of data that's been scraped, green space has had this representation, the most times. So I'm interpreting green space in this way, and then it might riff off of that to see, okay, green space had also pathways. I'm going to include pathways, and pathways, I think, look like this because all of the images produced of pathways have looked like this. And so it's not always putting things together in a sensible fashion. It's just kind of creating like a mosaic of the most common representation of each of the words that have been provided in the prompt. And so I think there's always going to be room for designers who are truly bringing that design knowledge and that artistry, and also an understanding of what good design is, which is something that generative AI does not have knowledge of and cannot contribute. And I think it's, a tool in the toolbox, but certainly should not be a replacement for any human-mediated design.
I really enjoyed your presentation. I was fascinated by the part where the users could test different scenarios. Have you seen evidence of that actually contributing to more political engagement with people? Or is it more of a fun thing to play on online, and then they kind of go back to TikTok and not contribute on the larger scale?
Yeah, that's a really great question. We've seen that it's most effective when it's coupled with NGOs or research institutions who can kind of guide some of that scenario modeling, and then also give citizens the tools to actually try to make some of those things a reality and not just have it be a superfluous exercise. So there are plenty of tools that already exist just online in the world where citizens can play around with some of those things. But I have found that it is really helpful to have the structure of knowledge around how to interact with the political processes and how to enact and embody what's been kind of configured in those scenarios to drive citizen participation to change. And it's not always existing NGOs or research institutions. Oftentimes, we've also seen collectives of citizens come together and like self-organize new NGOs to further some of these goals. There was a case of people that were seeing kind of a lack of care of trees in their neighborhood, and they organized a group to like collectively monitor tree health and then come up with various processes for ensuring, that trees are being watered and trimmed properly, sometimes doing those actions themselves, sometimes having the city do those actions. But that kind of organized collective is often necessary. And then another thing that we've seen to further facilitate actually enabling and enacting what's been modeled is the widespread proliferation of cheap sensors. So particularly on the transportation side of things, concerned citizen organizations can really easily acquire their own sensors and install them in the built environment. And we've seen a lot that they've collected data in that way, and then regularly gone to community meetings with representatives from their community to present the data that they've collected that the city has not been collecting or monitoring. And having those data does enable the city to understand, that these are problems for citizens and that they need to be responded to. So another example of that is in Vilnius, Lithuania. Citizens were quite concerned about air quality, and they filled out like a resident survey and implemented some activism to kind of promote that air quality was a priority for them. And the city was actually able to install a citywide air quality sensor network and then begin to monitor the spread of pollution in the city and respond to it accordingly.
You mentioned that, of course, AI has its shortcomings related to citizen participation because there's always going to be people that are not so tech savvy and cannot afford to have either time or the money to have these tools and access them. Do you think, can you think of any ways to reach these people, maybe even with AI? Because we are always losing some part of the population as much. We would like to be very participative and get everyone in, but some people just don't have the time or the money, the skills. Do you have any suggestions to be more inclusive about that?
Yeah, this is also a really big problem as more and more city services become digital, and it excludes people that don't have access to internet, don't have access to digital devices. So I can mostly speak to the United States context, but having centers where a city will staff it with, people that can provide training, provide internet, provide devices to underserved populations to be able to use that and understand how to interact with those technologies and systems and services is quite helpful. We have that in our libraries in the United States and in some city halls. in many areas in the global south. One example of that is in areas where UN Habitat is operating, and they have a need to map informal settlements because many of those are not mapped. There's a really, really strong aversion to having those locations be mapped because mapping leads to regularization, which leads to essentially often clearing of those areas. And so people lose their homes. And but like UN Habitat still needs the mapping so that they can understand how to provide critical infrastructure and services to folks in those areas. And so they build partnerships with people on the ground so that when they're doing, let's say, aerial data extraction, they'll hire people that live in the informal settlements to go and collect data for ground truthing. So for comparing to the extracted data, so that they can understand how the data are being collected and then have that skill set as well that they're gaining from doing the data collection themselves. And then also kind of apply their own insight into how the data should be collected so that it promotes the safety of those communities to the best that it can. So it's a lot of involving people in those creation processes and giving them roles in the formulation of AI algorithms so that they can understand from the get-go how those technologies are working. Another cool example is having like QR codes on sensors or interfaces in the urban environment that show the data coming from sensors so that folks can understand how those sensors are collecting their own data and then also view the output of those data to also understand how it might be used for decision making.
Thank you. Great. Sounds wonderful. I have personally enjoyed very much your presentation. Excellent content. Thank you very much, Sarah. I hope we can continue this conversation and using AI for good. Thank you very much.